So role of UV in the forest conservation and afforestation and reforestation. So I have started my journey in Meghalaya since 4 years, and basically I used to fly drone for various departments and get the data and give it to the concerned departments and do the different applications. So right now we are working for the forestry project. So most of the Meghalaya, 70% of geographical area is covered under forestry. So recently, 40% of forestry has degraded because of various reasons. Like maybe there are like a deforestation, mining areas, and shifting culture. Many reasons are there. So what is the major defect and availability of the data in the market? So what happened that satellites are available, but especially when we ask for the data, so whereas in the valleys, the data are not good. So there are cloud coverages, there are many drawbacks are there. Like we are not able to identify where this forest degradation happened. So now we are come up with the drone, then where we do the flying at a low altitude and fly a high resolution data. And this high resolution data can be helped in various applications. So one of the application is like identifying the forest degradation. So here you can see just like so what we do, like first we select the drone according to the application. Like there are 5 categories of drones we have: multi-rotor and fixed wing, and again VTOL we have, one helicopter we have, and solar-powered UAVs. So having the combination of drone and plus sensor. So drone is just nothing but a vehicle which can carry any kind of a payloads, either a sensor, like any kind of a like maybe a payload of medicines or seeds, anything.
It's to a global audience. It's global audience.
Sorry, can you hear me?
Yes, we can hear you.
Yeah, fine. Can I continue the presentation?
Yes.
Okay, fine. So having the drone and the combination of sensor, we do different applications like RGB sensor we have, and LiDAR we have, and the hyperspectral had to be procured, and thermal various sensors we have. So what we do, we choose a multi-rotor and fixed wings to combine this sensor and drone, and like there are many applications. One is the forestry that I am talking about. So yeah, basic steps involved in the drone survey. What we do, we select the area, then we do mission planning and pre-planning, and again flight planning we do, and then rapid image processing at the site. And after coming back and acquiring of all these images, we do data processing. So data processing again, like generation of orthomosaics, digital surface model, digital terrain model, and contours, various things we used to generate and give it to the concerned GS department. So from there, they do all kind of analysis part and then study about the project, what is degradation, what is the changes in the previous data and present data, and many things are there. So like there are some for like sensors like RGB, multispectral, and LiDAR. So here what we can do with the RGB. So here we can demarcate the boundaries of the villages and LULC land cover, land use maps we can generate, and also forestry maps and plant cover and canopy cover. So these are the things that we are doing right now. And using multispectral camera, we can also identify the forest health. So is there any like changes in the any kind of disease spread or maybe health disease or something? Maybe if water degradation something happened, or many reasons are there in the forest degradation. So we used to identify what is the cause, what is the root cause of the maybe the changes. So we do NDVA analysis, and automatically we used to generate the maps and then study over it, and chlorophyll also used to do. So having the LiDAR, we can penetrate, I think we can penetrate through the trees and get the ground information. So from there we can get the ground information and generate DTM. So this DTM helps in identifying the tree height. So having the tree height also, we can at least get this information, like that what is the age of the tree, then so what is the stage it is in the initial stage and the final stage. So and also we can also estimate the biomass and carbon estimation. So it can helps in hydrology maps and water management. So many are there. So what is the workflow? So how this actually completely end to end. So starting inputs are like drone survey. So we do the drone survey, and again that there are involving of sensors, acquiring of the data, and again we give it to the software. There is a called a Pix4D software and drone to map that we are using right now. So the data just we are to dump into the software. There it collects all the n number of images, stitched together, make a single map. Then that single map can be exported into any kind of ArcGIS platforms. Like we have here ArcGIS and the QGIS softwares, where we can do all kind of analysis. So having these data sets, like we do, like before I have mentioned land use, land cover maps, and canopy height, and then plotting a fish inventory, and then extracting tree heights. Many various parameters are there. And for forestry, we need a drone data also, and as well as field inventory data. The combination of these two can be helped in like planning of the reforestation things. And this is the flow, like workflow of UAV. So we can see the left side top corner, the drone can fly in such a pattern. It has a frontal overlap and side overlap. So frontal overlap means that we have adjacent images of 75% overlap and side overlap of 70%. So why we maintain this much high overlaps? Because of to get the more number of images. So we get the more number of images to like identify a 3D model like stereo pairs. So once we get the good number of overlaps and then generate the 3D model, from there, like the point clouds will be generated in the software. So after that point clouds are generated, so again it generates 3D model. So from there, 3D model is generated. Again, orthomosaic is generated, and digital surface model also generated, and digital terrain model is generated. So this digital surface model is nothing but it is including of all the trees, buildings, everything. So digital terrain model is nothing but it's a bare earth. So without of trees and the minimum the ground. So what we can do is having these two data sets, we can subtract like digital surface model minus digital terrain model. So we can identify the tree height or building height, whatever the height difference between the DSM minus DTM. So this is how we calculate the height of the trees. And again, like, having the high relation data. So this is one of the example that we used to plot each and every house and agriculture field and forestry. So we used to explain to the villagers, this is our field and we have like planted this many plants this year. You try to increase your forest canopy. Maybe you start expanding your forest area. Maybe you start decreasing your agriculture fields. So that is how we used to communicate and to the educate the villagers. So and also I'll just show you some more examples. So we can see this is the left side corner like orthomosaic image. So there is having this high relation data, you can also like identify the boundary of the particular villages and the state or anything. So what happened, like especially in the villages, when we go for the survey, we do the forestry, they say that this is forestry belongs to this one, this is ours, so we get confused. So we used to ask them to see this image and like mark the boundary. Like we can also like help them in like getting this proper boundary and authenticated. And also having this high relation data, we can generate contour lines. So contour lines are like having a same uniform elevation information. So we can using contour lines, we can get these hydrology maps also, and planning of infra cut and fill and analysis, many things we used to do. But basically we are using these contour lines and DSM for hydrology maps, micro watershed management. So to preserve the water within the village. So how do we like preserve the water? Making of some check dams or maybe some recharge holes or recharge pits. So there's Meghalaya is the highest rainfall area entire nation, I think. Yeah. So what happened recently, because of rainfall, the water goes down and we are facing water issues and all. So now we are come up with a new idea that we're making some kind of watershed management, like uh, like making a check dams and where is the water flow is going. So like that. So this is the left side corner, and this is the FSI data. This Forestry Survey of India. So we have they have divided as the green portion is indicating moderate dense forest, and the yellow color indicates that non-forest area. So, but after drone survey, we have further classified into a different classes. I think it's visible agriculture. You can see this is the agriculture land. We have marked as agriculture land, and also whatever they have said that it is a moderate forest or open forest. Again, further we have classified into a like maybe agriculture again and moderate dense forest and many further classifications we can do with help of UV drone data. And again, this is like, you can see this is the contour map and watershed management. Yes, and yeah, here you can see this is the village. This is the area of our interest. So this is the highest elevation. Then this is the catchment area for this particular village. So what we used to do, like when the water flow is there, so it's always from the top to bottom. So water flow from this elevation, like 1480 meters to this 920. So water is traveling from this place to this top corner. So what we do, we used to make a reservoir here with help of like kind of a contour maps and hydrology maps. So we preserve the water, we stop the water here, and the start helping these farmers, and also for the forestry we start utilizing this water conservation, and again plantation and all we used to do. So this is the one of the example that we have recently done. I think, yeah, this is what, and again limitations that we have. Again, satellite data, like it is very expensive, and also cover is like it covers only low resolution data on the cloud. It's not available cloud free data. And again for manned aircraft, and it is for large area, but we cannot use it for, it's very expensive for, especially in Meghalaya. We cannot fly these manned aircrafts, whereas drones can be easily deployed and get the data immediately for the small scale studies. And again for ground terrestrial technology, it is very difficult to access the places where the terrain is so tough. Even it takes 5 hours, 4 hours to reach one village also from one place to another place. The elevation difference is almost like 1 kilometer. That means 1,000 meters. So that in that places we use the drones to at least go there and fly the particular area of interest and get the information. So that is how we started covering all these places in Meghalaya. We are trying to cover almost like 70% of area of using drones and get the data. And for that, data can be utilized for many studies like forest conservation, and also like urban planning and road connectivity and various other projects if they need need it. I think, yeah, fine. And this conclusion is that yeah, drone can be utilized in many places like forest fire. One of the major cause in Meghalaya is that zoom cultivation. Once the cultivation is done, they start burning the field. So that again we used to monitor like till what extent this fire will be going. Again we used to like ask them to stop the fire from there. So, and again identification of deforestation areas and degradation, what is the cause, that we do study. And many kind of like studies we used to do with the drone. But again limitation is the flight time, and then and again the sensors are very expensive, and also the data processing, especially in the forest area. When we process the data, the trees are keep on changing their position. So in one image the position of the tree will be in one place, and another image the position of the tree will be different. So when the software start processing these data sets, so the like there is a kind of some blur or maybe some kind of smooth effects. These are the limitations that we are facing right now. And also especially with lidar, even if it is very dense forest, so what happened is cannot be penetrate through the trees and get the ground information. Only like where the some gaps are there, that particular places only it can be like go and get the ground information. So it is not accurate as accurate that we get the ground information. But again, 80 percentage of accuracy that we are getting using drones in the forestry and many applications. And I hope, thank you so much. And think I have missed so many things I thought of covering. Yeah, fine. And yeah, if you have any questions, please do ask me.
Thank you for sir for an amazing presentation. So before we move on with the Q&A, I have a question. So
Yeah,
when we are using drones near the forest and we have lidars, so are the lidars able
yeah.
to penetrate the canopy? And if in case these are not able to penetrate through the canopy or the foliage, what are the other subsidiary sensors that can do it?
One is the microwave, like SHAR data. SHAR we have in a satellite. So first I will talk about the LiDAR. So LiDAR, what happened just like a sun. Suppose if it is a very dense forest area, so you put a torchlight or you give a sunlight. Where is the sunrise goes down? Just same like that, LiDAR also can penetrate like that only. It cannot just go beyond the leaves and get the ground information. But whereas other sensors like SAR, like satellite aperture radar, it can Even I think microwave also can even, it can penetrate through the trees, the leaves, and then get the ground information. But again, it is very expensive that the satellite are like using those kind of sensors. But for UAV, yet to be like, into the market. I am not aware that it is available, but I don't think so. I think more research is needed for these kind of sensors.
Thank you, sir. And sir, what do you think about something like a synthetic aperture radar?
Mhm. Yeah, last time we have proposed a sensor like that only from basically I have worked in NISAC previously, so there was discussion about the SAR sensor for the drone. So the limitation is the payload; it is very expensive, and the power source. The power from the drone, and it is very limited for only to operate drone. And again, the power it is required for the sensor is again like it is a huge requirement. So then there is R&D is going on. I hope that maybe soon we'll see this SAR sensor for drone applications also.
Thank you, sir, for your answer. Do you have any more
Yeah.
questions? Please put it in the chat. Okay, as of now, I don't find any questions. So I would like to hand over the session to Dr. Ruchi.
Thank you so much, sir, for being a part of a conference. It's a pleasure learning from you and for all the lovely things that you do in the northeast of our country. And this was an amazing presentation. I really, really enjoyed it. And I hope to
Yeah,
have
thank you.
the opportunities of working with you in the future. Thank you.
Yeah, thank you, ma'am. Thank you. Thank you.